Bag. All right, so today my computer is doing this weird thing where it connects and reconnects, and I don't know what to do about that, but we'll do our best. So today we are going to talk about maximums and minimums on the graph and end behavior on the graph. And before we write any words down, let's just see what they are in the pictures. So looking at the pictures, you can see there are things called local or relative maxima. Local and relative maxima are the same thing. And you can also see that there are absolute or global maxima. They are also the same thing. So it's confusing when there's different words for different things, but I have to tell you all of them because I don't know what delta math is going to do to you. I don't know what an SAT test is going to do to you. I don't know which words they're going to use. So I got to tell you all the words. Okay? So basically, if you're the biggest overall, then you're a global maximum or an absolute maximum. If you're the smallest overall, you're a global minimum or an absolute minimum. And then you can also have minimums that are basically just the smallest thing around. A relative minimum is smaller than the points on its left and on its right, but it's not the smallest point overall. And you can see we have the same thing with maximums. A relative maximum, which is also called a local maximum. It can be the smallest point around, or the largest point around, but it's not the largest point overall. There are a few tricky rules, and we will include those in our definitions at the top, okay? So turning points are basically all of these together. Anything that's any kind of maximum or minimum is a turning point, okay? And basically the turning points happen anytime you switch from increasing to decreasing or decreasing to increasing. So anytime you switch between switches between increasing and decreasing, and it can be the other way too. Increasing and decreasing, you have a turning point. And it's basically the point you turn on. Okay, so all of these that we talked about just now, they're all turning points. When it just says maximum, they're talking about the biggest overall. All right, so when we talk about the maximum, we're talking about the biggest overall. So it can be called the global maximum or the absolute maximum, or just the maximum. Okay? And when we talk about the maximum, what we're looking for is the highest point. The highest point has the largest y value, not the largest x value, but the largest y value. So the maximum is going to be the largest y value in the whole graph. And of course, then the minimum could also be global or absolute, and it's the smallest y value. Okay, so sometimes graphs will be going to positive infinity or to negative infinity, and we don't count those as maximum or minimums, but we can't say that a different point is a maximum or a minimum because it's not. We have something bigger than it. So we just say that there's no absolute maximum or minimum if it is infinity, okay? So if it's infinity, we're just going to say no maximum or minimum. So you'll see examples of that later. Relative or local maximums, they have to be larger than the points right to their left and to their right, but they don't have to be the biggest overall, okay? So those would be y values bigger than the y values to the left and right of the point. all right? An endpoint will never be a relative maximum or minimum because an endpoint doesn't have points on both sides. So never an endpoint. Okay, and the relative or local minimum is going to be the same thing except it's the smallest, right? So it'll be y values smaller than the y values to the left and right of the point. And again, an endpoint cannot be a relative or local minimum. It can be an absolute max or min, but it can't be a relative max or min. So never an endpoint. All right, so let's take a look down here. What is our absolute maximum? What number? I heard it's 65. Anybody else think 65? 65, yes. Because remember, we're looking at the y value. So the absolute maximum, and I'm abbreviating, absolute maximum is 65. And I'm going to say is y equals 65. Now we also say the location with the x value, but that's really not the answer. It's just the location at x equals 7. I'm still trying to figure out exactly how delta math does this, but if delta math just wanted one number, it would be the y. This is the important part. This is just the location, okay? All right, what is the absolute minimum, the smallest y in the whole graph? I see one hand already. Wondering if anybody else wants to give it a try. 2 hands. 3 hands. Itsuka, what are you thinking?
Negative 14 and y equals negative 14.
Okay, Itsuka is giving us y equals negative 14. Alec? Annika? Same thing? Okay, so they're agreeing it's the negative 14 because it's the y value. That's very good. For some reason, my eye always goes to the x value, and I have a really hard time with that, so I'm glad you guys were there to help me with that. The absolute min is the y value, which is negative 14. That's the important part, but then we always do write the location as well, at x equals 1. All right, the other points are a little bit tricky to read. I'm just going to try to connect them so that I can try to read them a little bit better. I think my last class said that this was 40. Kind of close, right? And then they told me that this one looked like 10. I thought it was a little bit off, but close enough. Yeah, see, like it looks a little bit like 8 to me. But I'm happy calling it 10 unless you guys want to fight that. You guys are okay with 10? Okay. So what is this one here? Is it a relative maximum or a relative minimum? Relative maximum, right, because it's like a hilltop, right? So relative maximum of 40. You could say relative or local, yes. Those terms are equivalent. I'm saying relative maximum. You can say local. I just want you to be able to recognize them both. So relative maximum is y equals 40 at x equals 4. And then we saw that there was a relative min. And I think we decided we were going to let that be 10, even though it didn't quite look like 10. At y equals 10. And then at x equals 6. Okay? All right. I'm gonna have you raise your hand if you want to share something. It could be an absolute max, an absolute min, a relative max, a relative min, anything that you'd like to share. I need more space, so I'm gonna like go all the way up here too. Raise your hand if you have one thing you'd like to share. You get to pick what you want to share. All right, Alec, what do you want to share? Absolute min. Absolute min. Y equals -4 at what? At x equals what? Good. All right. I need someone new. Go ahead. Okay. Absolute max, none. Well done. And so I went through this with a few of you, but I know it kind of looks like this is your absolute max right here. But then we say, okay, but I also know that these are going to positive infinity. So really my absolute max will be positive infinity. But when it is positive infinity, we just say none, because infinity is not actually a number. Okay. Who's next? Raise your hand if you're ready to share something. We're gonna make somebody else do some work, okay? Go ahead, Julian.
I have a question.
Yep.
Is there no absolute max again?
Because the absolute maximum would be infinity, and infinity is not actually a number. So whenever your absolute max is infinity, you just put none. Same with minimum, if it went to negative infinity.
Relative max y equals 10 at x equals 2.
Beautiful. Okay. Ollie, what do you have for us?
Y equals 0 at x equals 0.
Beautiful. All right, raise your hand if you're ready to share something now. Feel like we have a couple more left. Annika. Okay, I see that one too. So these were both relative mins. She said local min, which is totally right. Just so that I'm saying the same thing, I put relative. Very good. And where's that last relative maximum? Do you guys see it? What's the y value of the last relative maximum? It is 6. Good. So we have a relative max of y equals 6 at x equals -2. And so notice like the phrase has both the x and the y in it, but the y is the most important part, okay? That is the actual maximum or minimum. It's the y. Any questions? Okay. So end behavior is what happens at the ends of the function. And it doesn't matter if your function, whatever happens in the middle, it does not matter. What matters is at the ends. And there's really not that many kinds of end behavior, right? If you have arrows at the end, they can either both be up, or they can both be down, or you can have one up and one down, or the other way around, right? So these are like all your choices. There's basically 4 kinds of end behavior you can have. The way they talk about end behavior is a little bit tricky, just the way it's written, but it's not that bad, okay? So you can see examples here. The left side's going to positive infinity, the right side's going to positive infinity, and then this one here, the left is going to negative infinity, the right's going to negative infinity. That was 2 of the 4 examples I just showed you. So let's look at this one over here. All right, so this notation is for the 3rd example over here, okay? So when it says as x is going to negative infinity, they're talking about the left side. Okay? So on the left side of the function, as x is going towards negative infinity, what's the y doing? Is it going up or down? It's going down. For some people, that's hard to see because it's different from when we talk about increasing and decreasing intervals, because we're not reading the graph left to right. We're starting in the middle, and we're saying, okay, as x goes to negative infinity, what's the y doing? It's going down to negative infinity. This one's talking about the right side. okay? So on the right side of the function, as the x goes to the positive infinity, what's the y going to? It's going up, very good. So it's going to positive infinity. Now the nice thing about end behavior is that we always write it that same way. The only thing they switch up sometimes is sometimes instead of y, they write f of x. Remember that y is the same as f of x? So it could say y, or it could say f of x. That's the only thing different. All right, so if the graph is going down, then we'll say the y value is approaching negative infinity, and if it's going up, it's approaching what? Positive infinity. Okay. So I'm going to do one of these examples with you, and I think it will probably finish right around lunchtime, and then you'll use the remaining time until lunch, and then when we come back also to try the next example. There's so much here, but it's basically all the things we've gone over in the past few lessons. It's just hard to look at them all at the same time. So I'm going to say, let's just think of them one at a time. All right, domain. Is domain x values or y values? It's x values, good. So for the domain, we're going to be looking at the x values. I'm going to put in my infinities here just in case I need them, okay? So starting on the left side, what's my smallest x value? What's it go to? This one, right? So my domain starts at negative infinity. It covers all my x's all the way through until the right side, and this arrow is going where on the right side? It's going to infinity. A lot of people want to say negative infinity because it's going down, but remember we're focusing on the x's, and the x's are going to positive infinity. So anytime your arrows are going left and right, you've got negative infinity to infinity for your domain. A lot of functions have negative infinity to infinity for their domain. All right, the range is slightly trickier. Starting at the bottom, where are these arrows going to? Down to negative infinity. So I'm going to start at negative infinity for my range. Going up, I don't quite believe this to be like all the way to 5. So what decimal could I put if it's not going all the way to 5? 4.7, I'll take 4.7. Yep. Okay. Okay. I will not, like on a test, I will not give you a point where you have to guess, okay? As long as you understand what you wrote, it's fine. Okay, so I like 4.7 because it's like more than 4.5, but it's not quite 5. 4.8 would be good, but whatever you guys think there. Okay, so your range went from your negative infinity up to your largest y value here. All right, increasing and decreasing intervals. That's talking about as you read the graph from left to right, is it going up, down, what's it doing, okay? Remember that what we do is we draw these dashed lines through each turning point, okay? And we use those to help us focus on the x values, because when we do increasing and decreasing, we always use x values and we always use parentheses. So I'm going to call this one -3, 1, 3, and then I'm going to put negative infinity and positive infinity here. And now we're just going to read the graph from left to right. So I've got this first part is increasing or decreasing. This part is increasing. It gets confusing when you mix it up with end behavior, okay? Increasing and decreasing, you just read it across left to right. So increasing from negative infinity to -3. Then it starts doing what? It's decreasing, thank you. From -3 to 1. -3, 1. Remember, always use parentheses on increasing and decreasing. And then it's increasing again. I'm going to put a U in between my increasing intervals to say this one and this one. So it's increasing from 1 to 3. And then it's decreasing again, 3 to infinity. So notice how useful it is to write the numbers down here, because you can just read those numbers off as you're trying to figure them out. 3 to infinity. Okay. So now we're going to do extrema. Remember, that's the new thing we did today. So we're going to look for our absolute maximum. Looking at our absolute maximum, remember we estimated it to be about what number? 4.7. So absolute maximum, y equals 4.7 at x equals -3. Absolute minimum. Oh, we don't have one, right? So none, because it's going to negative infinity. I'm going to have to probably move my end behavior down, so I'm just going to cross that out and do that in a minute. Okay, we need relative minimum. What's our relative minimum? Where it dips down? What's that value where it dips down? Yeah, so you're looking at the y value, and that's 0. So relative min.
Do I take the pass or just?
You can just go. Relative min, y equals 0 at x equals 1. And we have 2 relative maxes. I'm going to try to fit them in over here because I don't want to use up all my space. So I have relative max. Oh no, I just have 1, right? Because that was the absolute. What's the y value of that point? I think it's 3. Y equals 3 at x equals 3. And then we can do end behavior. And, oh, I wrote hey, hey twice. End behavior. Sorry, that's terrible. End behavior. Okay. The nice thing about end behavior is that it always starts the same. It always starts like this. As x approaches negative infinity, as x approaches positive infinity, and then we have to fill out the y part. So I'm just going to fill that out without knowing anything about my end behavior yet. As x goes to negative infinity, that's the left side. What's the y going to do? As x goes to positive infinity, what's the y going to do? Okay. So on your left side of your graph, as x goes to negative infinity, what's the y going to? It's here, right? Negative infinity? Okay. Now, on this side, I have a positive infinity written because that's an x value, but on the right side, what is the y going to? It's going down, yeah. So even though the x is going to positive, the y is going to negative. So both sides are going down, that's what I'm saying. The left side's going to negative infinity, the right side's going to negative infinity. They're both going down. It's tricky. So I'm going to ask you to take a minute to start this one because I have time to walk around and help you. And then when we get back from lunch, we'll finish it. You can start anywhere. If you don't like domain and range, you don't have to start there. You can start on increasing and decreasing, wherever you want to start.